maybe it's interesting. I always explain people what I do with this coffee machine, and you will all do similar things as me. And I think it's for you also a good introduction of like, how do you explain what you do? And basically what we do is we design this black box. So people have a user interface. They can change parameters. They can put a different strength of coffee, of sugar. All of this happens in the interface, and we design everything that's in the back. We make sure that this coffee comes out. And in general, if you program it right, it will work. And if there's any mistake, it's a human mistake. And there's also something here. This machine, for instance, doesn't put those little spoons. So I was going to do that myself. And I'm terribly at multitasking. So you can see a human mistake is very easily made. And then a bit about Sweco. Who of you already knew Sweco before this CodamX talk was initiated? I see one finger. So, well, we are actually the Europe's largest architecture and engineering consultancy firm. We have about 17,500 engineers, architects, and consultants. And Sweco stands for Swedish consultants. So 1/3 of our people are actually in Sweden, and about 10% of all of the engineers and architects are in the Netherlands. And to give a bit more overview of what we do, there's a video. I'm going to move with that one now. Can't see it.
Society. Transforming it is the most necessary and inspiring challenge we can imagine, and one Sweco is proud to rise to. Every day since 1958, we've been combining different perspectives and expertise to solve the most pressing challenges of our times. While those times have changed, the Sweco philosophy hasn't. We believe the collective knowledge of citizens, communities, clients, and consultants creates solutions that truly stand out and truly transform. You won't find us on the sidelines looking in. We're right here. In the midst of society's most seismic shifts and trends, we stand shoulder to shoulder with clients and communities, facing and transforming all our futures. Together we're addressing urbanization. Together we're capturing the incredible opportunities of digitalization. And together we're making everyday living ever more sustainable. That might be creating new careers in the world's greenest office building one day, helping endangered creatures safely across the road the next. Wherever transformation is needed, we're there to lead it, ever fueled by the insight, diversity, and scale of being the leading player in Europe and a strong local presence for focus, agility, and proximity to our clients and society's needs. In our ever more complex world, each Sweco consultant has the expertise, determination, and responsibility to solve the challenges of today with concrete results that spark new realities and transform tomorrow for all of us. Together. Sweco. Transforming society together.
Yeah, so transforming society together. We want to be close in the local business areas, and we want to challenge some challenges that we have to resolve together with our clients and together with communities. And we have 6 important themes in that. And we call them Urban Insights, which is our international knowledge program. So we also work a lot together in cross-border with other countries within our Sweco Group. And so we have, for instance, climate adaptation. We need to get our urban areas and also all of the other areas, but we need them getting ready for the new changes in the climate. Circular economy. Well, materials are scarce. They're not endless. So we need to be smart with them. We need to design our buildings so we can take it apart later and reuse it in different buildings later on. The energy transition. Of course, we all want the renewable resources, the renewable energy resources. But there's a larger problem underneath that, and that's the infrastructure. So we can put everything full with solar panels, but we need to be able to get the energy back into the system. And currently our infrastructure is not ready for that. And with increasing urban and denser cities, mobility and a healthy and a safe city will become more and more important. So those 5 topics are very important, but essentially I put also digitalization because it touches upon all of these topics. It can resolve things for all of these topics, while it's also a topic on its own. And that brings us also to the data challenges in our industry. So I want to take you with us to how our projects work and how data is generated within our projects. The core of this challenge is that we have, for instance, of these 17,500 experts, we have more than 100 disciplines, and each discipline has their own inputs, their own outputs, their own software that they use. So all of this data is difficult to match. They have their own regulations, they have their own information systems. So there's a lot of data inputs, but also a lot of data created, which is mismatching in file extensions, for instance. And a lot of data is reported in reports still. So let's say we would design a building. Then we have an interdisciplinary team. And I now focus on the structural engineer. And the structural engineer would take the codes and regulations, the creativity and the expertise, and make it into a structural design. And you will also have reports with the results. To work together across disciplines, we then take an extract of the structural design and put it into a BIM model. So it's a lot less information stored in there, and the real full information is stored in the archive. So the full data, it will be archived. And through this BIM model, we can collaborate, we can identify clashes, we can see what are things that we need to resolve together, and this loops over several times. So a short intermezzo. This is an example of a BIM model. So it's a 3D geometry, which every discipline has a part in it. You can see on the right-hand side, we have a structural beam. And you can see this is the metadata that's stored. So that's not much. It doesn't say anything about the structural integrity. And that's something we would need to add to really get our data in order and to be able to start doing stuff like AI and machine learning with. So if you have multiple disciplines, I mapped here the data streams that we have, and you can see most of it ends up in the archive. It will be stored in a project folder and later archived away. And what is left in the BIM model is basically the abstracts of each discipline, just to be able to interact. Another data stream that we shouldn't forget is the experience gained by every engineer. And that's going back into the heads of the engineers and the consultants. And what we actually want to do is to centralize all of this data, all of this experience, and put it into a digital twin. And the digital twin is a bit different from the BIM model, as you can keep it up to date with a building. So say you would move a wall because a room needs to have like a larger floor plan, then you would update it in your digital twin. And what we should start doing is making digital twins of all of our buildings and storing all of our archived information and our experiences in there. Because that opens new opportunities for us. You could, for instance, connect it then to Internet of Things. You can start monitoring, you can start doing all of your maintenance there, and then you have asset management. But most importantly, you are collecting data, storing data. And this can be very valuable for all of the consultants again. So say the ventilation system in a design is working not optimal. And We store this data, we get the monitoring, we get all of this data. We can learn from that and make in the next designs, we can take that into account. So the vision is to end up with sort of a life cycle of data where from initiation, you start with the data collection and keep on building on top of that. And most of the data will probably be generated in the asset management where you are doing the maintenance. It's also the longest period of time of an asset, the use time of the asset. Then we have the end of use, which then is used, since we want the circular economy, this data we can use for new project initiations. So how do we capture this data and maintain this data? Well, that's where you come in. We will need new roles in our industry. We will need new disciplines to change the status quo. And I defined some of the roles here. For instance, we need a data architect, someone that makes the blueprint how to store this data, and the policies and the governance to do this data collection. A data engineer to carry out this blueprint, to make the pipelines that process the data, and then data scientists that create new overviews, new data insights with predictive models. As we also need a connection with the status quo, the people that are now working in our company. So we need a data steward to improve the data literacy and to see what are the what are the things that it can help you with, basically. And I made this sketch as well, so you can see the data architect thinks of the blueprint, and the data engineer makes these pipelines. So you have these different data sets from different disciplines, and this pipeline basically structures it and gives it some extra metadata, which then the data scientist can take out of a data lake and make new predictions that are new insights for our engineers. And the data steward then explains the importance of all of this. Why is this helpful for us? And why are we storing our data as we are going to do that now? So now I would like to go into some practical examples. I earlier showed you the urban insight teams, and they all touch upon it. They all touch upon digitalization, of course. The first one is solar parking, which is relating to the energy transition. And there we wanted to kick off a project and to test the feasibility with as much insights of as much possible disciplines as we could. So I will go further into that later. Then we have the master connection, which centralizes our own knowledge into predictive tools. And Reclaim is also focused on the circular economy, and it is made to sort of bring out the data that we already have. So we have the life cycle of data as a vision for the future, but a lot of assets, they are already built. They don't have this data structure at the moment. So we need a solution for that as well. So for solar parking, we wanted to, in the energy transition, we have those fields that are covered with solar panels. And instead of doing that, we want to cover parking spots. And to do so, we sort of wanted to kick off by integrating as many disciplines as possible. And it seems a simple design, but there's quite a lot of expertise involved. For instance, you need a parking consultant, which calculates the amount of parking spots you can have, makes the design of the floor plan of the parking spot, of the parking location, the structure engineer to design the structure, a cost consultant to calculate all the cost, the solar power consultant to get the solar gains, which is where you can make the money from the energy you get, and the financial advisor of the feasibility. So normally we would do this project with among others, with these disciplines. And we added that digital integration team and the GIS services. And I have a small video now to show the tooling that we made. So this is our GIS system, GeoWeb. It's a product of Sweco, and we have our own developers working on that. And when you use this tool, you can draw in your own parking location. And this is important because the location determines the solar gain you get and the orientation as well. Then it goes to our parametric configurator, where basically, according to all of the rules that we programmed, it will give you a primary initial design. So you can, with the parameters, you can tweak them a little bit. And always there will be a verified design coming out of it. So these are all designs that you could make with this configurator. And now we can also perform a solar analysis. So we can calculate the gains. So then we know what kind of cost efficiency we will get if we would make a solar park in this location. So we use this for the initial phase, the feasibility. And if it's feasible, then we can kickstart the project very easily, since we already structured the data in such a way that it's verified and validated. And there we put it in the location for the client to see how it will look in their area. So I said we integrated a lot of disciplines, but we are missing actually a few still. The orange ones are included now, but an important one for the feasibility is also the soil research and characteristics. Foundation cost can be quite high, but this is a very difficult thing to predict. And we have a data scientist working on this at the moment to see how can we predict in locations to come up with a reasonable estimation of the foundation cost. And like I mentioned before, the network connection, the infrastructure is not everywhere ready to connect a lot of solar panels into it. It's actually becoming, at least in the Netherlands, quite a thing. I think the last few weeks I've seen it like multiple times in the news. So we need to upgrade the network as well. And this can be a bottleneck for any project, and therefore also the feasibility. Then we also still have the safety aspects, and the installation design is not included yet. If you have large areas, you also need to think that the fire department needs to be able to get there. So those things need to be included as well. And all of these other steps, they follow and make the life cycle of data. So the vision of this tooling is to, in the end, have some monitoring and that we can learn from each iteration that we do. So how does this change the status quo? Normally we would work with an array of engineers to get the first design and then check the feasibility. And now we basically, based on all those rule sets that we programmed, we kickstart the design phase. And our engineers, they only need to do the specials, the things that they, also that needs creativity, the problem solving. So this is quite a huge step. So if we can do this for more projects, it will be very helpful. And the idea is also to be able to unplug, for instance, the soil research and use it in another project. So within the vision of the life cycle of data, these are the first steps of project initiation and design. So starting to build your data as you can use it in all of the other stages later ahead. And you can enrich and build further on top of that. Another example I would like to show you is the master connection. I can only show you a prototype made in 2019 in Finland. It's still in development, but this is what we can share at this moment. And it focuses on these kind of steel structures. And you can see when steel members come together, we need to define some sort of connection detail. And that's what they focused on. In the Nordics, they have hundreds of these projects yearly. And each of these projects has hundreds to thousands of these kind of connections in the model. 10% is sort of unique, so a lot of them you can repeat. So you can copy-paste a lot of work as well, but still every unique one you spend 10 to 30 minutes on. So what they want to do is some sort of information sharing platform. So that's what the prototype did. The prototype was made with two fully modeled, fully detailed models. So it has all of the connections already in there, validated. And then it had a basic model with no detailing at all. So what the program did, what they designed, it sees where elements are intersecting. And then you know there should be a connection there. And in this case, there were 696 connections. And then from the database you created with the other two models that were fully detailed, with some nearest neighbor algorithms, then you can define which ones are perfect match or which ones are possible matches. And some are no match. So this overview, for instance, is already very useful because when you start a project, you know how much time it probably will take to design this whole structure. So I have a little video here as well to make it more, to show it better. So this is a model that's fully detailed. We will zoom in soon. And you can see all of those red dots, all of those orange dots. Those are detailed connections, connection details that have been modeled already. So first it looks for where are members joining. Those are those blue spheres. And then it collects all of the detailed information into the database. And then we get a model with no connections at all. And we do that first step again. So everywhere where steel beams touch, we know there should be a connection there. So we get the blue spheres again. And now for each of these spheres, we can ask for a prediction. So if we zoom in, then we can select one of those spheres. And it can ask the database like, okay, do we have something that fits these properties of the connecting beams? And in this case, it finds 100% accuracy. So you could then directly put this model, this detailed model, into your project. And you can also select for all identicals because it's often repetitive. So, and it's directly modeled into your design. So this is a huge game changer because if you imagine of those hundreds of projects, you can store all of this data. You will get smarter with every project you do. And of course, a structural engineer needs to validate and understand exactly what's happening there. So we will get early insights in how much work it would cost. And we accelerate our own processes. And somehow you also get some sort of uniformity across all of your projects. And in the future, you could add integral recommendations. Say you would add the cost of each connection or the carbon footprint of each connection. Then you can decide, because multiple connections can be a correct choice for adjoining beams. So then you can choose on cost or carbon footprint, for instance. And you can start monitoring the use of what our own engineers use a lot. And you can maybe upvote or downvote for certain reasons. For instance, if a connection is valid, but it is very difficult to make in a structure, you might want to downvote it because we would not like to use it again because it takes a lot of time in the construction site. So how does this change the status quo? Well, if we integrate multiple disciplines in this kind of tooling, well, first of all, we get smarter with every project. But all of these disciplines then can have a profit of it, let's say. So, for instance, the cost estimation, you can just take it out of your database because you know everything is structured. And this part is mostly in the life cycle of data. It's mostly in the engineering part. So the algorithm used here was quite simple. But the most difficult part here is the data architecture. Like, how do you store it, and how are you gonna get sensible information out of it? And the main gain is, of course, the centralization of knowledge. The last example I would like to show you is the prototype of Reclaim, which stands for Recovery Long-Term Asset Inventory Management. In circular economy, there's a huge problem that when you demolish a building, it can be decided within 2 months to demolish a building. And often the new designs where you would like to design with used materials, well, you often don't know where those materials are in the regional, because you also want to have it regional. So we came up with tooling in which we can close that gap. So normally you have like a design process like this. It can take quite some time to design a new project for, say, a high-rise building or something. But the materials, you have a very small window of opportunity because you don't know where they will occur. Where can you get the materials that are circular? And our vision is that if we can predict which buildings will be demolished, then we can ask those asset owners if we can check what kind of materials are there, and ask them as well if it will be demolished soon. In which we can, in every phase of our design, we can also implement parts of the circular materials. And we can time the demolition with the construction of the new building. And the prototype that was built by a data scientist was on a data set of the city of Rochester. I'm not sure if I pronounced it correctly. But it's a city in the United States, and they have an open database. So you basically plug the data of 2012 and 2021. And with this data, build a machine learning model to predict which buildings would be demolished in the future. Then she put in the 2012 data, and below here you can see the results. And so all of these dots are buildings that the machine learning model thought, okay, these buildings will be demolished. The nice thing is that since we ran it in 2012, basically, we know the data of 2021, we can check which ones were actually demolished. And those are the orange ones. So you can see there's a lot of them were actually demolished, and the blue ones are not demolished yet. And the reason for that is that the blue ones, they follow the same pattern as the orange ones, more or less. So for instance, this orange one had a 64% probability, and the blue ones, they also have, I think we have at least a 40 or 50% probability in this overview. So they match certain patterns that were recognized in the data. And here we show this data as well. So you can see this one was quite important, the assessment value of an asset. Most of the demolished buildings actually had a very low assessment value if you compare it to all of the buildings in the data set. The same for the land value. So here you can already see sort of the pattern that also the machine learning model picked up. So what does this change to the status quo that we have today? Well, since a lot of these assets, they are already existing in the world, they are not included in our life cycle vision yet. So in the end of use phase, we now can start including the existing unstructured data. And in the project initiation, we can have insights. Where can we get our materials? Where can we make a change? Where can we boost the circular economy? So if all of this is also very interesting for you and you're up for the challenge, we call it a revolution. So then join our revolution and help us close this life cycle of data. You're not alone. Normally before COVID, we always had like cross-border developer days. So then we would have hackathons for a few days, come together and extend a network of developers within the company. And if this all sounds interesting, contact our campus recruiter, Lindsay van Heugten. He has some contact information. If you later on have some other questions, please connect with us. So if you scan this, you will be redirected to our LinkedIn pages. And next week is also the Dutch Design Week. I'm not sure if any of you heard of it. We will also have a stand there. So visit us from 16 to 24 of October in Eindhoven. And we have an in-house day. There's still some spots available. And you can sign up through this QR code. So I think I talked enough. So I don't know, does anybody have some questions?
Yes, it works. Let's open up the Q&A session. And we'll use again the catch box, guys. So, who wants to ask the first question? Come on, wakey, wakey. Yes, 1 second.
Thank you. So you showed how the solar panels were used for the parking spots, and also how it could be calculated how much they would generate in terms of electricity. How did you get that data? Is that from Google Maps? Do you use satellites to like use weather data, or how do you know that?
There is an international database of solar gain, and it has a very convenient API, so you can just send your request, and with the parameters that we have from our model, it will come back. So,
thank you.
Does it also take into account shadows? I know, like, okay.
Yeah, so in this model, not yet, but we have other models that indeed they can select. If you select a roof or something, it can take into account where is a chimney and take out the shadow it creates. So we have it, but it's not included in this tooling yet. So.
Okay. I also have another question. You mentioned like you have a bottleneck with the grid capacity, right?
Sure.
But isn't that like something you do not have under control? It's like because I understand like you can only politely ask Nexus or Leander or Tenet, can we please have a connection? So isn't that like not something you can do anything about it?
Yeah, you can request that, and but partly you also pay for that if you make a big change. But in other parts of our company, we also consult these as our clients. So there's no influence on that indeed. So it can break your business case in this case. But I think the plans of all of these parties is to upgrade the network, but it's just such a huge, the energy transition is a huge deal, and it will take time. So certain parts of the Netherlands will probably have to wait to build this kind of solar parking. So it depends also on the size. So if you would make a small solar parking with just a few panels, it's generally not a problem. But if you have parking lots that are like near a harbor or something that are huge, and then that really is a game changer. That would really mean you need to add some new infrastructure there as well, and that would cost money. And that's something you should discuss indeed with the energy providers, the infrastructure providers, basically.
Okay, thank you.
Hi. What does BIM stand for again?
Building Information Model.
Thanks. Yeah, and I recognize it.
How far are you with the digital twins development? Because I saw like the use of digital twins even in the last example that you gave, right? So what if every single building in Amsterdam would have a digital twin? Then we would know exactly, what you can outsource out of a building, right? Because you will know what kind of windows there are, or the kind of floor, and so on, and what you can actually recycle. So I was wondering how much Sweco is actually working on the digital twins, and are you actually collaborating maybe with Cadastre, or what's the name of the registry in Netherlands, buildings registry? Just curious if...
Yeah, so there are some initiatives, and they are across Sweco Group. So I think Jit has more information on that. But basically, the difficulty is that not all clients ask for a digital twin. So then we also don't build it. Because basically when you have a BIM model, at a certain point it stops. So you deliver the project, but you would like to change also everything that if you go to the construction site, things will go differently than you have planned. So you would like to update the original model and start putting all of this data in. And the way I sketched the picture, I don't think it's being done yet, like to really put all the knowledge in. Because there's another deeper problem. So say you have this digital twin with all of this data inside it. You want to learn from all of those digital twins. So somehow you need a policy like the blueprint, the architecture, to actually get all the data of all of these digital twins and learn from it. So yeah, that's basically the huge challenge ahead for our industry.
But I also think that it's like the consumer or the client needs to be a bit educated on the importance of that, right?
Yeah.
Because I remember, I think I gave this example during our call, but maybe I can explain to the students. When I was working with Cadastre on creating digital twins for the buildings, it actually came from a good idea initially. So, and the idea was basically like the fire department, right? They want to know what kind of materials you used, when you first of all built the building, and second of all, in case if there was any renovations, right, specific type of paint that you put on the wall, or maybe you made some changes, and what kind of materials have been used there. Why? Because for the fire department, 3 minutes is life-saving. You know what I mean? So if they know the type of materials that are used in building the house, they can predict a better model of, basically how fast the house is going to burn down. Now, the interesting question was a lot of privacy and stuff like that, and education of the client, because imagine this, we are talking about maybe even not offices, but homeowners, right? So you all of a sudden make a change into your house, you yourself have to make the same changes, record them in the digital twin, correct? So then all this small details, the conversation was pretty interesting. I don't know how far, Cadastre actually went with implementing the discussion point that we had, but I know for a fact that they're actually considering to do this. And then for you, I think it would be easier as well, because if Cadastre says okay, every single building needs to have a digital twin, the clients have no say. They just have to pay for it, and that's it.
Yeah, but it depends what they store in the digital twin. Like the data that we now generate, in general, it will not be stored yet into the digital twin. So if you know the material, but maybe you don't have the capacity or the underlying documents yet. So the things that I'm discussing, I want to really put much more data inside. But yeah, if it will be mandatory, I think that would be great because the whole industry would profit from it because we can learn from all of those digital twins. But then the question is indeed, which data will you store and how will you keep it up to date? So.
Yeah. You said that one of the missing pieces was soil research.
Yes, in our workflow there, yes.
Yeah, because I kind of know about the Dutch regulations are quite strict on soil, and if you want to build or renovate, you need to do all these samples. But there is a GIS system for all this. I think it's quite detailed already.
Yeah, it has quite some data inside it. What we want to do is to make a prediction. So we will not replace the current workflow because indeed, according to regulation, you will also still have to do samples. But for the feasibility phase, it could be good to know if you have an 80% chance on having a pile foundation of X cost and 20% for a cheaper foundation. And then when the project goes, you will really look into it. Or maybe if it's 50-50, the client will say, I want to do a sample there to see what is the truth. So that's basically how we are thinking about it. But indeed, I think you discussed talking about Prolocat, Locat. But they have indeed like
Amsterdam is completely filthy. It's all dirt.
Yeah, but they have a lot of areas, but they don't have everything either.
Yeah.
In the Netherlands, so that's another problem. You will have missing points. So we were thinking of making a model that just increases decreases the accuracy.
Yeah.
How far you are from real data points.
Interesting.
So I have a question about the reliability of the data you get. You just said to the gentleman that asked the first question that the data is from an API, but how trustworthy is it?
Now this one is from a government institution, so that's why we also use that one because we have quite a high level of trust in it, and we think it's more reliable that it will stay online as well. So when it would be offline, that part of our tool would not work either. Okay. We have some more in-depth methodology that we have different data sets, but those are still manual work. So if you would go for a next step and you think maybe there's something to gain there, you could do another analysis, indeed, with some more local data as well.
So this software will only work if the government has a lot of data of its own country, about its own soil.
Well, this database, I forgot the name, what it was, but it's basically a global one. So you can just pick a point and you get the information.
Nice.
So we could do it everywhere, but since all of the codes that we programmed, also structurally and stuff, are the Dutch annexes and Dutch codes. We have, of course, Eurocode, but we have some regional differences. We only keep it for the Netherlands now because we need to alter our algorithms if we would go to, for instance, Germany or Belgium.
Okay. So. Anyone else?
I think at some point you mentioned that one of the roles of a data scientist is model. So to what extent does that include physics models? Because I can imagine that plays a role in industry as well. And
do you mean in building physics or predictive models for energy systems? Or
yeah, for example, simulations for whether structures are sound or what kind of efficiency you get with, for example, the solar panels or maybe
I think once
wind turbines.
Like we have also a team that does only monitoring, and for instance, the data they would get, you could indeed start building models based on sensor data, things that are really time marked, and you can upgrade then your, for instance, if it's an installation that's being monitored with the sensors, you can then make new calculations and new predictions based on that. Is that what you mean, sort of?
But I think what he meant more is like the so it's data modeling, okay? And then inside there, like the data engineer, was this for data engineer? Which role were you talking about? The data engineer?
Scientist.
Yeah. So I think there you actually have multiple people that is advising this one guy, right? One developer. And, he has to talk to the building engineer and the electrician and whoever else, and gives him knowledge about the specific expertises. And then this guy, because he knows how to develop, data models, takes those principles into practice and builds the model. Is this the way it actually happens?
So it would always be in close consultation with the expertise holders. But the data scientists would build then from the data sets that they have a predictive model. So I was mostly talking about predictive models like machine learning models or deep learning models.
So actually, it doesn't mean that you need to go and have a physics degree or engineering degree. You can be just a data scientist, and then you just collaborate with multitude of people that actually have that knowledge. And then eventually, you have to, I think still you need to grasp, to understand, what they're saying and be able to transform it into this regressions or whatever stuff you build there as a developer, because I'm not a developer, so.
So general, all of our projects, they are generally interdisciplinary, and this data scientist would just be a new discipline in the team. And we already have some projects going like that. So that really brings that discipline into the project team. So you should indeed always see it as a collaboration. That's also the nice thing that you mentioned earlier, that across the 17,500, we have more than 100 disciplines. And in a building, like if you design a building, you already have I suppose 8 to 10 disciplines working together, each with a different role or in different parts. So maybe the structural design is very important, so that's a big part, and the cost is just a day's work or 2 days' work. But they have to work together, and data science and also data engineers and stuff will become part of these kind of projects. And in those building physics things, there's of course, because you can do monitoring, you can collect a lot of data. So that's really a nice place for also doing some predictive modeling.
Yeah. Thank you, Edwin. Let's give a round of applause for Edwin. This presentation is one more time a proof that you need, developers everywhere. Literally, the example of the metal structures that you can actually calculate all these connections, with data science and stuff. I mean, such a simple thing, right? But you don't even realize that there is potentially a developer behind it, And to be honest, thank you so much for opening our eyes towards the architecture and, engineering and construction industry, because we look around and we see buildings, but we don't really per se understand the things that are happening behind it. So I truly enjoyed it. And one more thing as well, thank you for the slide with the different types of data engineers, architect, and whatever. Because for me, it's like puppity poopity. I never knew what it actually means, each of them, right? So at least now you enlightened me with the knowledge. Guys, you will be able to rewatch this session again on YouTube. I will actually ask Edwin if it's okay if you could share the slides with us, and we can share it on Slack so that you can, always go back and get inspired. Guys, sweco.com? .nl.
NL for the Dutch side.
Okay.
But
So-
for the rest.
Keep an eye. When you're ready for an internship, you might want to just knock at the door of Edwin potentially, or better, the Lindsay, who's the tech recruiter, because Sweco is trying to build a more sustainable society. So most of you, every single time I talk to you about, your potential internship, you always say, "Oh, I want to do something good for the society." Well, there you go. Okay, guys, thank you so much for attending. I hope you registered yourself with Danai. If you did not register yourself with Danai, please approach her on Slack so that she can check you in, okay? Because you're going to get 150 points for your coalitions, right? So that's what I'm saying. Okay, thank you, and I'll see you next time. Thank you.
Thank you very much.